All right, so this is going to be the Leetcode number 150, evaluate reverse Polish notation. And I'll just start the timer uh, again and go through the problem, go through the algorithm. Yeah, so let's start. So you're given an array of strings tokens that represents an arithmetic expression in reverse Polish notation. Evaluate the expression, return an integer that represents the value of the expression, okay? The value operators are positive, negative, multiplication, division. Each operand may be an integer or another expression. The division between two integers always truncates towards zero, which I'm guessing means it should be an int, because converting it a division because dividing two operands and converting that to int will remove the decimal points. There will not be any division by zero. The input represents a valid arithmetic expression in a reverse Polish notation. Uh, okay, 32-bit integer. Okay, so it's going to be integer. So taking example one, tokens is 2, 1, the plus operator, 3, and the multiplication operator. The output is 9. How did we get output 9? Well, 2, 1. So 2 plus 1 is 3. 3 multiplied by 3 is 9. Okay. So they just added the previous two numbers here. Took that result, multiplied by 3. Okay. Tokens 4, 13, 5. Division, positive. Positive operator. So we have 6. So 4, 13, 5. So they took division, divided the two previous numbers, and then added it to 4. Okay. Tokens, taking example 3, all of that number, 10, 6, 9, 3, positive. So in this case, they took, for example, the first operator, added 9 and 3, um, and then multiplied by negative 11 from that result. Okay. So, and a pattern I'm seeing is that whenever we hit an operator, we take the previous two numbers and then apply that operator to those operands. So, and actually, I'm going to handle a case where basically if the token, if len token, or I'll say if token equals an empty list, I'll just say len token. I don't know if this will return equals 0, then we return, I'll just return 0. Right? But if not, then, we go through. So basically, if you take the example of the first example, right? I'll take the first example because that's going to then I think translate to all of these other examples. So we take the first example, 2, 1, positive 3, and multiplication. Basically, what we can do is have another list 2, right? And what we can say that for whenever we hit a operator in the tokens list, right? What we do is so basically first we keep appending the strings for strings and tokens into list 2. Once we hit an operand in tokens, right, you what we do is we pop the last element from list 2. So this is going to be, for example, number 1 is going to be actually this is going to be number 2. List 2 dot pop, right? And number 1 is going to be list 2 dot pop, right? So we pop the last elements, right? And what we do is, and actually let me do this. If we hit an operator tokens, right? You do that, um, right? So yeah. So and then what we'll do is check what the operator is. So if the operator is equals positive, then you do number 1 plus number 2, right? And then if the operator is, negative, then you do number 1 minus number 2, so on and so forth, right? And what we do is just append the result we have to the list 2, right? Because we need that result to then apply the operation to other elements of the list. So for example, in this case, if we take 2 and 1 here, so this will be 2, this will be 1, right? So this will be list dot append 2 plus 1, which will be 3, right? And then since list 2, now what will happen is once we add 2 and 1, this will be 3, and then we can multiply 3 and 3 together from the tokens list, right? So this will be my code here. So basically what we can say is, so if we hit an operator, um, so for token in tokens, right? If token in positive, oh, is positive, division, negative, or multiplication, then what you do is, and actually let me define a list two here. List two equals an empty list. So what you do is you take number two equals list dot pop, right? And number one equals list dot pop, right? And let me list two actually, list two. And because these are string, we'll convert it to an integer, right? So these will be integers here. Um, right? So we're gonna say if token equals the positive operator, then you would just simply add those numbers, right? So you do number one plus number two, and we'll actually append it to list two because we need that result to then calculate all of the other operations, right? So you would do that, and then it's just simply just copy pasting all of this. Um, right? And I'll just change the operators here. Um, oh, and I would just convert this integer, this division into integer just in case that it doesn't return a decimal point here. The last that's left is this, and this should be it. So, oh, and then I forgot that if token is not in these operators, then what you do is we just do list to or sorry, token or sorry, no, list two dot append, list two dot append token, right? Uh, yeah, I think that should be it. Yeah, I think that should be it. Let me run this. Oh, sorry, it should be tokens. Oh, okay. So, oh, I didn't return list. Oh, sorry about that. I don't know why didn't I do that. So return, uh, because we'll have only one element in the list, we'll just return list to the first index where because it's after we calculate all of this, we're gonna be left with one result in list two. Um, yeah, a wrong answer. Okay, let's see. So why did we have a wrong answer in here? So positive division, negative, and this. Okay, token in this. The case one is fine. Uh, oh, no, no, no. It should be number one. Wait, because if I take the example of 2, 3, 1, Um, so wait, so list two will be two and one, right? The first one will be one, the second one will be two. So it should be, yeah, number one plus number two. Because if I take the example of two, one plus three, um, and let's say this was subtraction, right? Um, it should be two minus one, not one minus two. So this will be number one minus number two, right? And yeah, this should work. This should work. Yep. Okay. So yeah, I think that was pretty much it. Um yeah, any questions, feedback, let me know. All right, I'll end this.